Okay, girls, so example one. AB is a building, so I just drew the building in AB, which is perpendicular to the horizontal plane BCD. So let's go find our horizontal plane, because this one looks a little weird. We've got BCD. This is the floor. That is the building, and let's pretend we've got two strings attached to A, points D and points C. Okay? Which means in this triangle ABC over here, this is a right angle, and in this triangle ABD, angle B over there is a right angle. Okay. It says the angle of elevation from point C, so looking here to there, line of sight, that's the horizontal, which means that is theta degrees. BCD, BCD, that whole angle on the horizontal plane there on the floor is beta, and BDC, BDC, which means this horizontal plane field is alpha. The distance between C and D is K meters. We want to calculate the height of the building. Now this is exactly like the previous example that we tried to do, where we need to see which triangle over here, because that's what we want to know. We want to know what AB is. Do I have anything in triangle ABD that can assist me in determining AB's length? No, we don't have angles or side lengths. In this triangle ABC, we can see that here is our common side. In this triangle, and in the bottom triangle. Okay, which means now we want to be able to use this bottom triangle to figure out how to determine BC. Now we know we can use the area rule, the sine rule, or the cosine rule. Now the area rule can't be used because we don't have the area. But we do have two angles and a side, and I need to have another side. So the easiest rule for me to use is then the sine rule. So if we look at triangle BDC, we've got angle D, which is an alpha, angle C, which is a beta, and K. So I've just drawn this triangle out separately so that you can see it. I need to know what the height of AB is, and this is the common side for this triangle and for that triangle. So if we're looking at this triangle, I'm going to use the sine rule. Please excuse my 2-year-old drawings for this point in time because I'm still not used to drawing on anything, but we know that we're going to put our unknown side first. So we sit there and we're going to go BC over sine D, opposites, right? And then we end up having here, this angle over that side. But I don't have anything on that side. And I want this side length to help me with that angle. So what I can do is I can determine angle B. Now, how do I determine angle B with the information that we know? Well, we know that all the angles within a triangle add up to 180 degrees, right? So this angle, we can then write angle B must equal to 180 degrees minus these two angles, beta minus alpha. That's what I know angle B is going to be. So now I know what angle B is, and I have the side K that it matches. So let's go write that in. I'm going to go equals to, remember, it's the side on top first, so it's side DC, all over sine B. So BC we don't know, we still want to find it. BC over, can I substitute D, the angle for D? That is sine alpha, which is equal to DC. DC is actually K, so let's substitute K in, over sine beta. So what is sine beta in this case? Well, I can simplify this down into sine 180 minus alpha plus beta. All I did was put this into brackets. Okay? That helps me because this is reduction formula then, right? So we end up having, and we can rearrange and get BC by itself. So BC is equal to K sine alpha all over, how do we reduce this? Do you guys remember? Let's do some thinking work in a different color, orange. So if I want to reduce that triangle, I know that we've got cast here. I know 180 minus goes here, and it's in my sine quadrant. Therefore, this can be reduced to a positive sign. So we end up having sine alpha plus beta. The 180 falls away. Are you guys happy with that idea? We haven't finished answering the question. We have just found the common side. So this common side is BC. It's K sine alpha over sine alpha plus beta. Now I want to find out what AB is. Now that's a basic trig ratio. We know, I just want to make sure I'm in the right color. We know that if I want to find out what AB is, I've got that angle, I've got the adjacent and the opposite. So that ends up being tan theta is equal to opposite, which is AB all over BC. AB is what we want to know, so I can rearrange this by going AB is equal to BC tan theta. But what is BC? Well, BC is all of that. So I can substitute, let me substitute BC in with a different color, just so that you guys can see what it is. BC is K sine alpha all over sine alpha plus beta, and we're going to times it with tan theta. And that can be rewritten as, oh, you can just leave it as that. So that's your answer. There you found AB in terms of alpha, beta, theta, and K. Pause the video, watch it again. I do apologize for my 2-year-old writing. I hope it does get better during our lessons.